Hello students, this is a mini lesson on the inverse trig functions. So inverse relationships we have in math, addition and subtraction are inverse operations. You can also do an inverse of a function. One way to think about inverse is with an analogy. So if you have a person, then you can connect them to their fingerprint. That's like their output. But if you have a fingerprint, you can connect it back to the person. So this is a real life example of an inverse function. Here we have our table of trig ratios. And to do the inverse function, what we're doing is instead of finding the sine of a 30-degree angle is 0.5, instead of finding this number, now we're going to work the table backwards and we're going to go find the angle measure. So inverse trig functions are if you want to find a missing angle. The way to do it is I would look in the sine row and I would go try to find this number 0.4848. So I'm going to look in the sine row and these numbers are getting bigger. Ah, I see it. It's right here. 0.4848. Okay, so what angle measure gives me that for the sine? The angle measure is 29 degrees. So I know that the measure of angle B equals 29 degrees. I can do more of these. Maybe I could do this one, the cosine of W. If I want to find the measure of angle W, I know its cosine is 0.6157. So I can look in the cosine row. And here's cosine of a 60-degree angle is exactly 0.5, exactly a half. And I'm going to go make the angle get bigger, smaller. And I'm looking for 6. Oh, I found it. It's right here. Whee! So that's in the cosine row. So if I want to know the angle that goes with that, I'm going to go across the table to the left and see that the answer is 52 degrees. So an angle that has 52 degrees has a cosine that goes with it of 0.6157. So here's how you could do it. Remember, if the ultimate goal is to solve the whole triangle. So I could find this missing side using the right triangle theorem, a squared plus b squared equals c squared. But now that I know the inverse trig functions, I can actually find the missing angle. So this is the angle I want to know. This side is opposite. This side is adjacent. And this side is the hypotenuse. So, which two do we have? Which two side lengths do we know the measure of? We know the opposite side length and we know the adjacent side length. So now it's our chance to decide which of these three trig functions is going to help us. Okay, this is a little mnemonic device that you can memorize to just have the formulas stuck in your head. If you say so, ka, to, wa, you kind of, it's kind of like a chant. And it's an easy way, it's a mnemonic device to remember the formulas. So, ka, toa. So for this one, we have the opposite and the adjacent. So we're going to use the tangent ratio because that's the one that has the opposite and the adjacent in it. This has the opposite and the hypotenuse. We want the opposite and the adjacent. So next thing I'm going to do is I'm going to write the tangent of any angle. I'm going to write my formula out is the opposite over the adjacent. Even though I have it right there, I'm going to put that in. Make sure you're writing the angle symbol. That's important. Some people go too fast and just put tan equals opposite over adjacent, but that's not right. It's the tangent of some angle is the opposite over adjacent. Okay, next thing we do is, in this case, we don't know the angle measure. So I might put, let's label that angle. Let's call it angle A. So the tangent of the measure of angle A is equal to 14 over 29. Did I do that right? Yeah. Okay, now here's the fun part. So I know the tangent of some angle measure is equal to 14 over 29. There's a few ways I can proceed from here. I can divide 14 and 29 on a calculator, and I would get 14 divided by 29, this decimal, 0.4827. So 14 divided by 29. Oh, I can do that, 0.4827. Okay, and then I can go to the trig table, which I had, and I can go try to find this number in the tangent row. So I'm looking in the tangent column of numbers, and I'm looking for 0.4827. 0.4877. It's kind of between these two. So if I look across the table over here, it's kind of between 25 and 26, maybe a little closer to 26. So that's one way to do it. Another way to do it is to use our inverse trig function. So I'm going to do the same thing on both sides. I'm going to do the inverse tangent, that's the way we write it, of the tangent of the measure of angle A, and I'm going to do the inverse tangent of, I'm going to put it back as 14/29 because that's more exact, okay? Now, what does a function and its inverse do? Well, if you add something and take it away, that's the inverse operation. It kind of goes away. So the inverse tangent of the tangent is just the measure of the angle. That's what this is going to tell us. It's going to tell us the measure of angle A. So if I want to know the measure of angle A, I can type this into Desmos and it will tell me. So to find the inverse tangent, you look in the functions and you can see there they are. There's the sine, there's the inverse sine, there's the cosine, inverse cosine, there's the tangent, inverse tangent. That's the one we want. And then we're going to do 14 divided by 29. It's going to tell us pretty close what the angle measure is. And it was between 25 and 26 and a little bit closer to 26. I often round to the nearest angle measure. So I would probably round this up to 26 degrees. So really cool. The inverse trig functions give you the measure of the angle. Okay. Okay. Pretty darn cool. I did it. I found the measure of the missing angle. I could also find this one, and I could finish solving, like I said before, by using the right triangle theorem. Let's practice another one. Hey, look, here's a missing angle. Let's call it B. What's this? Opposite. What is this side? Adjacent. And what is this side over here across from the right angle? That's the hypotenuse. All right, so what am I going to use? I'm going to use SO, CA, or TOA for this problem. Sine, cosine, or tangent. And the formula is right there if you memorize it. SO, CA, TOA. Yeah, this one I'm going to use, I have the 11 where the opposite is, and I have the 27 where the hypotenuse is. So that's an H, by the way. Opposite over hypotenuse. So which one has the opposite and the hypotenuse in it? It's the sine function. It's the sine ratio. So the sine of any angle is its opposite side divided by its hypotenuse side length. And then for this problem, we're going to do the sine of the measure of angle B. And that's going to be 11 over 27. And this is going to work exactly the same way. This is going to be, I'm going to do the inverse sine of both sides. And this time I'm just going to keep the 11/27. I could put it as a decimal and look on the table and see what it is. Or I could not. Okay, did I do the same thing on both sides? Yeah? Okay, and then what's the inverse sine of the measure of angle B? I want to play with that for a second. So if I have, when I go to my functions, I'm going to do, well, let me just do the sine of a 30-degree angle. You guys know what that is, right? Exactly a half, right? The sine of a 30-degree angle is a half. What if I do the inverse sine of the sine of a 30-degree angle? So that's the inverse sine of 0.5. What is this number telling me? It's telling me the measure of the angle. So you can see it right here, the inverse sine and the sine, they undo each other, and it's just the 30 that's left over. Okay, the inverse sine of the sine of a 19-degree angle is 19. This is a really complicated way to write the number 19. Okay, the inverse sine of a 45-degree angle is 45. The inverse sine of the sine of a 45-degree angle. Okay, all that to say, for this problem, we have to do the inverse sine of 11/27. 11 over 27, that's the relationship between the opposite and the hypotenuse. And the inverse sine is about 24 degrees. So that all of this goes away and the measure of angle B is 24 degrees. That's cool. Don't overthink this, you guys. You can do this. All right, last example for this mini lesson. Here is an angle over here. Let's call it angle R. Okay, and this side is the opposite side. And this side is the hypotenuse side. Well, this is the same problem we just did. I'm gonna do it fast. Okay, I'm deciding between sine, so, ca, or toa. And in this problem, I have the opposite and the hypotenuse, so I'm going to use sine again. I'm going to do the sine of any angle is its opposite side over its hypotenuse side. And for this problem, I want to find the measure of angle R. And I know that the ratio is 12 over 24. 12 over 24. Do I already know the answer to this? What's the relationship between 12 and 24? Well, we'll find out. Okay. I'm going to do the inverse sine of both sides. I'm going to pretend like I don't know what's happening here. I kind of jumped the gun. So this is going to tell me the measure of angle R. And let's go put that into the calculator. Inverse sine of 12 over 24. And look, it's already in there, so I don't have to retype everything. Huh? 30? Why? What's 12 out of 24? That's a half. Okay. So I should have known this was a special right triangle all along. This is an exact number. This is exactly 30 degrees. If I drew the rest of the triangle, you would see, oh my gosh, Miss Bliss, that's a perfect equilateral triangle. And this is 12, and this is 24, and this is 12 times the square root of 3. And all of these angles are 60. And now I've solved absolutely everything. Woohoo! And all I had to find was the measure of this angle. All right, know your special right triangles and you will do better. Be good, keep working, and keep learning.